Hello, this is Britt Caswell with another example video. In this video, I'm covering example 2 from section 3-5 in the SavvasRealize Algebra 2 textbook. So in this video, we are trying to understand how a multiple zero can affect a graph. Alright, so a multiple zero is just a zero whose factor appears more than once. In a polynomial. So for example, here x minus 1, if you set that equal to 0, you'd get that x is positive 1. It's a multiple 0 because that appears 4 times because of that exponent there. So to start out, it asks us how a multiple 0 affects a polynomial function. So there's a couple of things. For the first thing, graphs behave similar to the exponent when it's close to the 0. So, for example, if there's a multiplicity of 2 is going to behave quadratic. Okay, multiplicity 3 will behave like a cubic, and you'll see that as you guys practice with this stuff. The other thing to remember, even multiplicities do a touch and turn. Okay, so they touch the x-axis and then turn back around. Whereas odd multiplicities, just pass through on the graph. Okay, so let's check it out. So the first thing is to state each of the zeros. So I have x equals 0, x plus 4 equals 0, which gets me x equal to negative 4. And then I have x minus 1 equals 0, so x here equals 1. So this 0, the multiplicity is 1, so this is just going to pass through. For x minus 4, again, the multiplicity is 1, so it's just going to pass through. And then x minus 1 has a multiplicity of 4, so it's going to touch and turn. So if I were drawing a quick graph or a rough sketch of it, what I'm saying is I could start by graphing my zeros. Mind you, this isn't going to be a perfect graph. It's a sketch because you know, I didn't calculate my minima or maxima or whatever. So x equals 0, when I go to draw the graph, I know it's going to pass through somehow. It might be, you know, it might have an end behavior going down and then coming up like this, or it could have an end behavior coming down like that. So we just have to pick one test point just to see what it would look like. So real quick, an easy test point would probably be let's just do like -2 or something. Okay, so I'm going to pick a test point. That way I know how to orient my graph. So I have -2 times -2 plus 4 times, oops, not x, -2 minus 1 to the 4th. So here I have -2 times 2, and then -2 times -2 minus 1 is -3 to the 4th. -2 times -2 is -4, and -3 to the 4th is 81 Oh, Lord, I don't know what that is, so bear with me while I take out my handy-dandy calculator. So 4 times 81 gives me 324, and it's going to be a negative here. So at -2, this function's like way down here. So I know that my graph's going to come like this. Now, at -4, it passes through, right? So my end behavior is going to come up like that. At 0, again, it passes through, so this graph is going to cross through the 0, make a little loop, and come down. And then at 1, we have a touch and turn, again because of that exponent. So it's going to touch at 1 and then turn back away. It doesn't pass through the axis. So my graph looks very roughly like that. Alright, so now let's check this out. So here, these are going to produce imaginary solutions, or imaginary zeros. So these will not appear on the graph. What they'll do is they will perhaps cause a bend in the graph somewhere, but we're not going to worry about it. Alright? So for my zeros, I have x minus 1 equals 0, so x is 1. And I have x plus 2 equals 0, so x is -2. Now if I look at the multiplicities, here this is to the 5th power, so this is going to pass through. And here the x plus 2 is squared, so this is going to touch and turn. So if I do a very quick rough sketch of my graph, alright, my zeros again are at 1 and -2. So all that I would need to do is pick a test point to see what this middle behavior would look like. And then I can use those end behaviors I could use the behavior at these points to tell me how the graph will appear. So I'm going to pick 0, because 0 is really, it's an easy number for me to work with. So I'm going to get 0 squared plus 9, 0 minus 1 to the 5th, and then 0 plus 2 squared. So this turns into a 9. 0 minus 1 is -1. To the 5th is still -1. And then 0 plus 2 is 2, which when I square it is 4. So at f of 0, I have a -36, which is down here somewhere. So I know that my graph is going to at least loop like that. And it probably has a bend in there. So now let's check out how these things help us. So here at -2, because I have the even power, I'm going to touch and turn. So I'm going to touch this 0 and then turn away. It doesn't pass through. And then here at 1, it says that I'm going to pass through. And that's because my multiplicity is odd. So this just crosses through like that. So there's a rough sketch of the graph that we get there. So that's how to use a multiple 0 to help us to change the graph a little bit. Until next time.